So here's homework set number 9. Where we're going to get to is building a roulette wheel. So here's the roulette wheel, the stepper motor spinning around. What you see on the display is the winning number. Winning number is 5. The current number, where the stepper motor should wind up, 700 steps, and where the stepper motor currently is. So how do we do that? That's where we're going to wind up in homework set number 9. Here are solutions to homework set number 9 for ECE 376. The first problem is to measure time 200 nanoseconds using timer 0. And with that, measure how long different things take. For example, this code right here measures how long it takes me to hit all 8 buttons consecutively. So go 0, 1, 2, 3, 4, 5, 6, 7. That was 4.2038114 seconds. Try it again. 3.00904757 seconds. Okay, so with timer 0, you can measure time insanely accurately. For example, if I want to measure how long LCD out takes, what I'll do is I'll measure the time before, I call the routine, measure the time after, take the difference in time, and that tells me that the LCD out takes 6.2543 seconds. Hitting all 8 buttons sequentially varies. This time it took me 2.3142262 seconds, or it hit RB0 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1.364465 seconds. So that's the neat thing about timer 0. With timer 0, I can measure time insanely accurately. Problem 2 looks at generate a chord. So to generate a chord, I'm going to play 4 notes at the same time. On RC0, I'll play 130 Hz, RC1, 146, RC2, 164, and RC3, 174 Hz. Now to do that, I'll use 4 different interrupts. To calculate the number of clocks between interrupts, that's 10 million divided by 2 divided by Hertz, gives you these numbers for n. For timer 2, I have to do a little bit different. A times B times C gives you this number. The other ones, I can do them directly. And what the interrupt service routine does is, for timer 0, 1, and 3, I just set up the next interrupt and then toggle a pin. Timer 2, I have to set A times B times C, gives you n. Make that equal to 30,337. And I should get the frequencies dead on. For example, if I go over here, slide this over. Here's a frequency counter. This is RC0, should be 130.6 Hz. I'm getting 130.9. Come over to RC1, 146.9 Hz. RC2, 164.8 Hz. And RC3, 174.6 Hz. So there I'm playing all 4 notes at the same time. With interrupts, excuse me, interrupts I can do 5 things at once. The 4 interrupts play the 4 different notes, and the main routine, all it does is just count. So we come over here. Here's the main routine. It's just counting for no reason other than to count. Finally comes the fun one. This is the last problem. I want to build a roulette wheel. And what that does is looks like this. It's going to spin a roulette wheel around and then land on a winning number. So for example, if 0 is up here, what this displays is this is the current number that the roulette wheel's on. This is the winning number, how many steps it currently is, how many steps it should be. So at RB0, the winning number is going to be 6. It spins around and then stops at the winning number. Actually, 6 is right here. I stalled the motor. So let's try that again. Winning number is 3, which is right here. It spins around 3 times and then stops. 0, 1, 0, 1, 2. Oh, 3's right here. 0, 1, 2, 3. Winning number is going to be 6, 4, 5, 6. Over here, that'll be the winning number. And again, winning number will be 7. That's right here. So that's the roulette wheel. How do I do that? Well, I'm going to have a couple different interrupts running. What I'll have is, I forgot the flowchart. Okay, I've got a flowchart, one for each interrupt. Timer 0, what timer 0 does is it steps every 10 milliseconds, and if I haven't reached the final step, this guy right here, go 1 step. Timer 1 just keeps track of time to 100 nanoseconds and generates 100 nanoseconds. Timer 2 is set up for 1 millisecond. When timer 2 is turned on, it'll beep. And the frequency of the beep is set by timer 3. So what the code does is I've got the 4 different interrupts. What timer 0 does is this is set up for 20 milliseconds, or 10 milliseconds, I guess. With prescaler of 8, this is 100,000 or 10 milliseconds. Every timer 0 interrupt, if the step of the motor hasn't reached the set point, the desired number of steps, that's these numbers right here, it's going to keep on going until I get there. And this is trying to slow it down at the end. I didn't actually do that because it wasn't working. So if reference is less than step, go plus 1 step. Right here. If I'm at the number, I'm going to set a global variable beep to 100. That says beep for 100 milliseconds. And then drive the stepper motor. What timer 1 does, that keeps track of time to 100 nanoseconds. Timer 2, this is every millisecond. I'm going to decrement beep to 0, stop at 0. Then timer 3, this sets the frequency. Here's your frequency. If 100 milliseconds hasn't elapsed, toggle RD0. That's where the speaker is located. With 4 interrupts working together, you get this characteristic. And timer 0 is stepping the motor. Timer 1 is keeping track of time, and also my random number generator. Timer 2 is setting the duration of the beep to 100 milliseconds, and timer 3 plays the note, 173 Hertz. Then the main routine, this is just enable, 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 enable. The main routine, what it does is wait for you to hit RB0. When you do, take the current time mod 8. That's my random number. This is where the motor currently is, mod 200, currently where it is in steps. That's what the winning number. Here's the current number of steps. I'm going to spin, or reference is the winning number plus 3 rotations plus 600 plus the winning number times 25. So that's the actual winning number. I'm going to keep on going until the stepper motor gets to the winning number, until these two numbers match. I continue to display on the LCD display. Here is the current number that you're at. There's this guy right here. My number is 0 through 7, 0 through 7. Display the current winning number. Display where the motor is going to wind up at 675 steps, and where the motor currently is, stopping at 675 steps. So that's the roulette wheel. To check to see if it works, I can sit there and check to see, are the numbers in range, 0 through 7. So I ran a couple times, and here's the data. Yep, there's numbers 0 through 7. It's spinning 10 milliseconds per step, and if you look at it, it's about 2 seconds per rotation. 200 steps per rotation, 2 seconds per rotation. The beeping noise is 174 Hertz. We did that back in problem 2. And to measure the 100 milliseconds, well, timer 0 is 1 millisecond. It counts to 100. That'll be 100 milliseconds. For statistical analysis, is this actually a fair die? Well, I only have 10 data points. If I want to do a chi-square test with 8 bins, I probably need like 80 measurements. I didn't do that. I just took 10. So instead of having 8 bins, I'm just going to have 2 bins, even numbers and odd numbers. Well, it turns out 5 of the numbers were even, 5 are odd. So based upon that data, it looks like a fair die. To be more certain, I need more data. And demonstration, one more time. The roulette wheel. Let's turn off that light. And that's homework set number 9 for 376.